Assalamu alaikum guys, I am Gazan Frawley, your chemistry tutor, and today we are going to talk about the Wittig reaction. Wittig reaction is a very important organic reaction in which there is formation of alkenes takes place when the aldehydes or ketones are treated with Wittig reagent. So firstly we discuss what is Wittig reagent, and it is also known as triphenyl phosphonium Ylide. Formation of Wittig reagent. What is Wittig reagent? Triphenyl phosphonium Ylide. This is known as Wittig reagent. We use 1 degree or 2 degree alkyl halide, 1 degree or 2 degree alkyl halide, then we add triphenyl phosphine. This lone pair of electrons attack on the electrophilic carbon, bromide ion eliminated, and there is formation of this intermediate. In the next step, we add a strong base. The strong base is butyl lithium, or we use sodium amide. Butyl lithium or sodium amide deprotonate this intermediate, and there is formation of Wittig reagent. It is also known as Ylide. We can also write Ylide as carbon double bond PPH3 and R prime. So this is called Wittig reagent, that is used in Wittig reaction for the preparation of alkenes from aldehydes and ketones. So we have a 1 degree alkyl halide. Our first reagent is triphenyl phosphine. Then we add a strong base like butyl lithium or sodium amide, and then we add a aldehyde or a ketone. Here I add a ketone. And what's happened? Then we get an alkene like we get this alkene. Mechanism of reaction. We synthesize Ylide, that is also known as Wittig reagent. In the first step, we add dimethyl ketone. What's happened in the first step? In the first step, this negative charge attacks at the electrophilic center. Then there is formation of so these two methyl groups that are attached with this carbon, one alkyl group with this and other alkyl group with this carbon. In the next step, there is a bond formation takes place between the O negative and PPH3 positive, and we have In the next step, triphenyl phosphine oxide eliminated, and there is formation of alkene. There is formation of alkene. Alkene is synthesized from aldehydes and ketones by Wittig reaction, and triphenyl phosphine oxide generated. So this is the mechanism of Wittig reaction. We have a 1-degree alkyl halide, then we add triphenyl phosphine. It's a strong base and a ketone, that is the cyclohexanone. Then there is formation of an alkene. So this is the reaction, and now we discuss the mechanism. For example, we have CH2Bi, that is 1-degree alkyl halide. Triphenyl phosphine attacks on the electrophilic center, and this bromide eliminated, and there is formation of or CH2 PH3. In the next step, we add butyl lithium, that is a strong base, and there is formation of Ylide. Ylide is formed, or it is also known as a Wittig reagent. In the next step, we have a ketone, and this Ylide the negative charge of oxygen attacks on the electrophilic center, and there is formation of this intermediate. In the next step, there is bond formation takes place between O negative and PPH3 positive, and in the next step, triphenyl phosphine oxide eliminated, and there is formation of an alkene. This alkene is synthesized by the Wittig reaction. Now we discuss some other examples of Wittig reaction. For example, we have a ketene, we have a ketone, then we add Ylide. Reaction is very simple. This oxygen and this CH2 are displaced, and there is formation of alkene with triphenyl phosphine oxide. Similarly, they are displaced. Alkene is synthesized with triphenyl phosphine oxide. What is the limitation of Wittig reaction? Tetra substituted alkenes cannot be synthesized by Wittig reaction. Tetra-substituted alkenes cannot be synthesized by the Wittig reaction. This is all about the Wittig reaction, in which there is formation of alkenes takes place when the aldehydes or ketones are treated with the Wittig reagent.